Welcome everybody. Thank you so much for joining us today for the webinar with Ridhwana Khan. And today we'll be discussing problem solving techniques for software engineers and beyond. And I hope that you enjoy it and get some value from it. So my name is Krystle. I am the head of marketing from FinChatbots, and I'll be your host for this webinar. This is our agenda. So our purpose, and we were just discussing this with Alice earlier, our purpose is to make this webinar a little bit more fun, a little bit more interactive, and of course, very valuable for you. So we're going to start with a welcome and introduction by myself. Then we'll go through the process of problem solving with Ridhwana. And then we'd like to stop there and have couple polls and a few questions from the audience, and I will turn on your mic so we can chat and make it a little bit more interactive that way. Then Ridhwana will take us through what happens if we get stuck or we're unsure with problem solving, and then provide a conclusion. Then we'll have another 2 polls and a little bit more Q&A, and then we'll give thanks and give closing remarks. So I'd like to begin just to tell you a little bit about our Meetup group. So at the moment, we're at about 1,790 members, and our goal is just to supercharge that and to continue growing it. The name of our Meetup, as you know, it's Johannesburg AI, Machine Learning and Chatbots. And FinChatbots started this Meetup group, but it is very much supported by French Tech in Cape Town and Johannesburg. And I'll tell you a little bit more about FinChatbots and French Tech a little bit later. So our Meetup group, the purpose of it is to actually create a community. It's really important to build an ecosystem so we can all support each other. So we're trying to create a community of entrepreneurs, tech enthusiasts, engineers, investors, corporates and students. So quite a nice solid ecosystem there. And then we would like to engage on topics like entrepreneurship, startup life, tips, deep learning, AI and chatbots. And that sort of really extends further into a lot of technology subjects, because as you know, there's so many incredible advances that are happening at the moment. So we would really like to address that. We would also like to have more hackathons, so we're looking at planning that at the moment. We did have one last year. Meeting and pitching, so if you have a really cool startup idea, we can work together to bring the right people together in the room to do that. And then of course, you know, with everybody that joins, let's open up that opportunity to have shared learning. So we've had some amazing speakers on our Meetup, and this is not all of them. This is just a few of them. So we've got Natalie, Amira, Rossetti, Alex, Karen, and Julian. And all of these people are really experienced on particular topics and agreed to share their knowledge with us. So we're very grateful for our speakers and very grateful for you, Ridhwana. So to tell you a little bit about FinChatbots and French Tech. So FinChatbots is a fintech startup that was started in Cape Town. Our main offices are now in Johannesburg. And what we do is we develop conversational AI solutions to help financial service providers acquire and retain customers while reducing operating costs. And at the moment, I think we're at about 16 team members, and we're based in Norwood. A little bit about French Tech. So French Tech's based in Cape Town and Johannesburg, as well as many other places in the world. But the Johannesburg charter is mainly run by our co-founder, Antoine Parasal. And the vision is very similar to what we'd like to accomplish with this Meetup. And that's all around building, and it's a network of people that are focused on building an ecosystem of entrepreneurs, investors, and engineers. So our philosophy is very closely aligned with that. So we work quite well together. This is the FinChatbot team, and I'd like to show them because they are so fully supportive of all of these events and help us to coordinate and make them happen. So yeah, you can give us thanks by joining our LinkedIn and Twitter page. We'd really appreciate that, and sharing the news about our Meetup page. So before I hand over to Ridhwana about problem solving, I'd like to leave you with a quote by Albert Einstein that said, "Intellectuals solve problems and geniuses prevent them." So I think, Ridhwana, this is an interesting quote, especially ahead of your talk, talking about problem solving techniques, but we found this to be quite an interesting quote. And yes, before we go, I'd like to thank everybody that joined us today. We really, really do appreciate your support. Thank you again to the team, and thank you for Ridhwana for supporting us and giving us this talk today.
Awesome, thank you, Krystle. That was a really good introduction. I actually realized I know a lot of those speakers that you have on the Meetup page, which is great.
That's fabulous.
Okay, so I'm going to start sharing my screen quickly, and then I'll get started. Okay, just give me a second. Okay, does that look good to everybody? Or to Krystle, maybe you can just let me know.
Oh, good, yes.
Awesome. Okay, thank you so much to everybody for attending. I see that we have quite a few participants, and I'm really excited to be doing this talk in collaboration with FinChatbot. So thank you to Krystle and Dale for having me, and to Liesl for introducing me to them. So I'm just going to give a little bit of an introduction to myself and what I do. So my name is Ridhwana Khan, as you all know, and I'm currently a senior software engineer at Dev. You may know it better as Dev.to. It's basically a learning and sharing platform where you can post articles and you can write articles and you can have discussions about anything that's sort of tech related. I consider myself very lucky to be working at Dev because I feel like it really intersects with the things that I'm passionate about. So I'm passionate about learning and sharing. I'm particularly passionate about building communities. And of course, being a software engineer, I'm very passionate about coding and about problem solving. In addition to working at Dev, I also run a nonprofit organization. My nonprofit organization is called Kasimet. We are based in the education sector, and the main goal of Kasimet is essentially to expose students to STEM and to essentially help them to understand the foundations that they're learning in school and how they'll apply to their careers afterwards. So we teach them a lot of problem solving skills. So a lot of my presentation as well today is just the learnings that I've got from sort of helping the students at Kasimet every day to be able to problem solve. If you're keen to follow the things that I learn on a daily basis or just like get random thoughts that come into my head, you can follow me on @RidhwanaK on Twitter. I'm pretty active, or you can read some of the stuff that I post on Dev.to. So today I'm talking about something that every engineer basically needs to do on a daily basis, and that's problem solving. I say every engineer, but in fact, it's just every human being, right? In our daily basis, we are constantly solving problems. Sometimes they're really, really small problems, and sometimes they're much huger problems. Sometimes they're problems that we've solved a million times before, and we're kind of already experts at, so we don't even regard it as problems. So things that are really simple would probably be like, I don't have children, but things like changing your baby's diaper like the 20th time, it no longer becomes a challenging problem. It's just something that has become part of your routine. Or using a stove, the first time you buy a brand new stove, it's a little bit challenging to use that stove. But after you use it for the 10th or 20th time, it's no longer a problem. It's because you've acquired the skills to be able to solve that problem. There's other problems that are more challenging and dynamic on a daily basis or on a weekly basis. So something like what route to take from, for instance, Joburg to Cape Town and how to avoid traffic, or how to, if it's raining on the way, what's the best route to take then, how to get from Joburg to Cape Town safely and avoid areas that are a little bit, that have safety concerns. We find that the more problems that we solve and the more we reach into our tool belt and we form processes and techniques to solve the problems, the easier the problem solving becomes. So before I dive into the methods and techniques that I use for problem solving, I'd like to talk a little bit about why I find this topic fascinating. And so I'll lead with a story of how I came into the industry. So taking you back to when I was in high school, I didn't know what a software engineer was. In fact, not a single person in my life at the time was in any sort of STEM fields, none of my family or none of my friends. The public school that I attended didn't have any computer labs as well. I'd never seen any HTML, CSS, or any sort of program before, essentially. And quite frankly, I wasn't super familiar with the internet either. My parents actually were pretty annoyed when we used the dial-up internet and the phone would go out of service simultaneously. I think I may have revealed my age with that statement, but it's okay. So in my matric year, like every other young adult, I was faced with the dilemma of choosing a career path that I wanted to pursue. And like every other young adult, I wasn't quite sure what I wanted to do. So what I did is I looked at a list of options that FITS offered. And at the time, I was pretty good at maths. I loved maths. And so naturally, I just sort of looked at the courses that were available and I said, okay, this course requires the highest mathematics mark as entrance. Let's do this. I didn't know what computer science was, like I mentioned. And also I hadn't done any computers at school. We didn't even have a computer lab. But FITS did say that there was no computer no computer knowledge required in order to be able to study computer science. So I was during my first year, it was just anxiety upon anxiety. I was great at maths, like I mentioned. It was my superpower. But other students in my class already knew how to program. So they knew what a while loop was, what a for loop was, and they were building applications already. And I had not even seen an if statement before, or I didn't know what a variable was. So during those years, between the crying and the anxiety, I often cursed at FITS. And I told them, I was constantly just in my mind thinking, why weren't they upfront with me? Why didn't they tell me that I was going to fall behind because I didn't know what an if statement was and I didn't have computer knowledge? But then 10 years later, reflecting back, I've somehow come to the conclusion that I didn't necessarily need to know how to program when I entered university. Computer science has a high requirement for maths because if you pursued maths, it meant that you were willing to problem solve. And computer science is actually about problem solving. And the programming language that we use is simply the tool to be able to execute the solution. So yes, whilst it was challenging to be able to write an if statement or a while loop, the actual core of computer science was problem solving, and learning the tool in order to be able to problem solve wasn't as challenging any longer. Tools can be picked up. I mean, everybody knows there's a new programming language or new framework every other month. But in essence, computer science never changes. And at the core of my computer science degree is the ability to understand and to find solutions to problems. And then I use the appropriate tool to implement my solution so that a computer will be able to cooperate with me. Once I understood this, it made sense that I focus on building my problem solving skills. So I felt frustrated many a times when solving complex problems. Many of the times I've had to take a step back and I've had to remind myself that I can do this and that nothing is unachievable and that I have the capability to do whatever I set myself out to do. Yeah, after many years, I still give myself that pep talk. And that pep talk is absolutely amazing. Coupled with my power pose like this, I can suddenly feel like Superwoman. So that's me, a Superwoman. But that's not all that gets me through these trying times, right? It's the way that I handle myself and the steps that I take in order to solve the problems. Having some sort of process in mind and some sort of techniques helps me to reduce my anxiety and my sense of overwhelm. So during this talk, we're going to go through techniques that I use in order to solve problems, and it's going to be in the following order. I'm going to talk about sort of just being focused and then being able to know and understand your problem, to be able to break up problems, plan a solution, write some pseudocode in the context of software engineering, and then execute that solution basically. Finally, we'll end up with some insights on how to overcome any road bumps, and then a conclusion, as Krystle mentioned. In between, there'll of course be some interactive sessions as well. So let's get started. So it's important to get the correct mindset for solving problems. I find that if I don't actually sit down and deliberately try to solve something, I can sometimes go round and round in circles for hours. And as I was chatting, if you joined a little bit earlier, you would have heard the conversation between myself and Alice. And we were talking about managing your time and being able to have focus time. So usually what I do is I tend to carve out some actual focus time and I plan for solving my problems. I grab a coffee, or in my case, I don't drink coffee, so hot chocolate, and I prepare my mind. I like to start out with determining what I actually want to achieve from a focus session. Because if you know what you want to achieve from a focus session, it means that you actually move towards those goals. Thereafter, the first thing that I do is to be able to know and understand my problem. This sounds really simple, right? Know the problem. I mean, people always talk about what the problem is, and it's pretty simple in theory to know the problem. But early on when I started my career, and like most newbies in the development industry, I wasn't as confident as I am right now. And so essentially what would happen is I would sit in meetings, we'd be talking about solutions for a problem, and either because I wasn't in the loop or I didn't have enough previous contacts, or maybe I was just slower to the party because I was a newbie developer, I didn't always understand what the problem is, and we'd already be at the solution stage in the meeting. So how could I have been valuable in those meetings where solutions were being mapped out when I struggled to even grasp what the problem was? And as a newbie developer, I was always scared that the people that I interacted with were going to think I'm incompetent for not understanding the problem, or that I wasn't experienced enough. But after some time, I eventually found my voice. And what I would do is I would clear my throat and I would lift up my hand and I would say, hey folks, can we possibly take a step back to just chat about what the problem is so that everybody is on the same page? And guess what? It works like a charm, and nobody respects you any less for wanting to ensure that you know what the problem is. An even better solution that I found recently when I started as dev, and the way that the world is going asynchronously, a great way to ensure that everybody is on the same page and everybody understands what the problem is to suggest a document write-up of the problem. And any thoughts on it prior to the meetings or discussions about solutions should go into that document, so that every person in a meeting can read up what the problem is before starting to discuss solutions. Knowing what the problem is doesn't necessarily mean that you understand it. Boy, don't we all know that. Sometimes when the problem is defined or communicated to you, there's a whole lot of jargon in the mix, coupled with very context-specific knowledge and loopholes. I've not only been in situations where I don't know what the problem is, but I've also been in those where I don't quite understand the problem. So what I do is a couple of things that help me to understand the problem better. The first thing I do is I ask questions. I've seen people around a boardroom table, and someone uses this term, and I think, oh my God, am I the only one that doesn't know what this means? And on the side, I'm trying to Google it whilst they're talking, but then I miss everything else. And after the meeting, sometimes I've gone up to someone else and I've asked them, like, what did that mean? I didn't quite understand it. And it turns out that they didn't know it either. But I thought that everybody else in the boardroom knew what the speaker was talking about, and I was the only one that didn't. But in fact, everybody didn't really understand it, but nobody wanted to ask questions in case they look incompetent. So it turns out that nobody could actually apply themselves to this problem because they didn't understand the whole picture. So one of the important lessons that I learned is to raise your hands and to ask questions. I truly believe that there are very few silly questions. Once you think you understand the problem, I find that reiterating it to someone to ensure you have the correct understanding is really valuable. I usually say something to the effect of, I see what you mean. Do you mind if I explain it to you? Do you mind if I explain to you what I think it is you're describing? And that way I can ensure that we're not missing each other. Firstly, it shows the other person that you are actually trying to understand the problem. And secondly, it will definitely make you feel vulnerable, of course, because it will expose the gaps in your knowledge, but it will also make your knowledge stronger than ever. You'll then be fully equipped to be able to start problem solving. I mean, nobody likes implementing a solution halfway to realize that they didn't fully understand the problem. If this happens, it can sometimes lead to financial or time wastage consequences. I find that visualizing a problem as well can be extremely useful. So rather than merely using data points and words to describe, analyze, and solve problems, using images really helps. Images helps the brain to clarify ideas and underlying patterns of logic. So as opposed to numbers and words, they have sort of a good visual will invite the eyes to dart around and to sort of engage the entire brain to create a visual logic and make sense of the information to which it is being exposed. The more fully the brain is engaged in the act of analyzing and creating meaning, the richer the outcome of the problem-solving activities will be. Visualization will allow your problem solving to also be more interactive. So I'm sure most of you know that like storytelling really engages someone. And so I feel like creating a visual is sort of implementing that storytelling for the user. And something, just an off comment is I've been watching Money Heist recently, and I found that when they were trying to get into the Royal Mint and essentially print out all the money, the way they did the problem solving was all visualization on boards. That's the way that they got away with almost €1 billion. So it must work, right? Finally, the last step that I tend to do, well, not the last step, but a parallel step that I like to do is I like to gather information. This can be done through talking to people who have solved something similar. Talking to someone like that can help you to see the situation more clearly. It will help you to look at the problem in different ways, identify options that you haven't thought of before. And I also do some research and gather information from the internet, articles, and insights on how people have solved similar problems before. There's no use in reinventing the wheel if something similar has been done and it's been done well. In the asynchronous world, these processes would become easier because we'd have documentation in place to have asynchronous conversations to help you to understand what the problem means. And that knowledge will essentially live on forever. So if someone new on the team joined, they'd be able to see that information on a document instead of it living within sort of meetings between people. One important thing to note here is don't try and force a solution without fully understanding the problem. I truly believe that sometimes, especially where humans are communicating problems, the most difficult part of problem solving is to actually understand the problem. So I'm going to use a simple problem throughout sort of this presentation as an example. And the reason I'm using this problem is because a couple of years ago, it was actually really relevant to me. I was working in the telecommunications industry, and I was constantly building components for sort of usage graphs within telecoms. So I would basically display your usage as an internet user, a data user on some sort of portal. So the problem we're going to use is you have to build a component that will display a graph with data on another system. So that's a very vague sort of statement. So the right questions for me to ask always in some meetings or in documents to understand the problem better was things like, what is this external system that we're getting data from? How do we connect to this system? what sort of data do we pull from the system? Is this data time series aggregated? And will this determine what type of graph we'll display? How often will we pull the data? For what period will we be displaying the data? How will the data look? How do we want the graphs to look? How many graphs are we building? So you can see there's a lot of questions. But once I work through answering these questions and gathering the information from other people, I begin to understand the problem better, and I can work towards sort of moving towards a solution. So once we sort of understand the problem, the next step is actually, the next step is to break up the problem further to be able to work towards a solution. When we understand the problem, it doesn't necessarily mean that we feel more at ease. Often when I understand the magnanimity of a problem, I go into like blind panic mode. I feel like the problem can't entirely fit into my head and I feel overwhelmed. That's because I don't have a deep understanding of the problem. And this is where I take a deep breath and I remember that everything can be broken down into bite-sized pieces. Big problems are absolutely nothing more than a collection of small little problems. And the faster that you can break down those big problems into small solvable components, the faster you can generate ideas that will resolve your biggest issues. Breaking up complex problems into smaller ones in their simplest form allows one to rationalize about them more easily. So I find that I spend critical time breaking down the big problems into smaller and smaller and smaller and smaller ones. And it enables me to take smaller first steps at solving the problem. And suddenly that anxiety and that feeling of overwhelm just goes away. So what I'd encourage you to do on a big problem is go to a whiteboard somewhere and ask yourself, what is this big problem composed of? What are the smaller issues that drive this big problem? And once you have those smaller issues, break them down again and again and again and continue breaking them down until you say, oh, I know how I might solve that small component of it, and then start joining the dots back upwards. When you start seeing the solutions emerge, you're moving from the problem identification stage to the problem solving stage. The time that you invest in dimensionalizing this problem solving space is going to help you to solve the problems more quickly and definitely more effectively. So let's go back to my example. So there's a couple of main sub-problems to solve. So if I'm talking about building a component that will display a graph with data from one system, with data from another system, I'd probably be breaking it up into a couple of sub-problems. The first sub-problem would be to connect to that external system to get the data, to be able to transform the data into something more usable and consistent for my system, because we have that system, we have my system, and now we need to get the communication between them. To expose the data via my API to a client-side application. So if I'm building like a single-side application on my application, I need an API and a front end. And to display the data from my API to the user, to the front end, so that the user can see it. And that suddenly makes a lot more sense, because now I can see we have three parts. We have the external system, we have my system, and my system will have an API and it will have a front end. Everything seems so much easier to sort of process in my brain. And then I'd have some subtasks and I can start planning out my solution. So this is where it may differ based on your problem. The problem above is a very technical one, so it will involve a technical solution. But if it's a business problem, it will be a little bit different, but it will essentially follow similar techniques. So when I plan out my solution, it can sometimes feel like I'm just breaking up this problem further and further and further, and that's okay. Because that's what we want. At this stage, we're moving from the problem identification stage to problem solving. So I'm basically connecting the dots of the subtasks to form a holistic solution. I like to start my plans with like, I need to do these actionable steps to be able to solve the problem. And then I make that plan flexible enough so that I don't become discouraged. You want to think about what you have to do to get from problem solving to a solution and what resources you may need to use. This is a good time to also fill in the blanks and do more research on different methods available to you in order to plan the solution. This is also the ideal time to evaluate your options without any financial repercussions, because if you're going to do it during execution or further along, there's going to be repercussions. Using diagrams and workflow for planning solutions are really valuable. These can be things like process flow diagrams. They're a good way to determine the flow of your solution and the different paths that you can take, the different options available to you. Maybe even a UI sketch. There's been so many times when I've suddenly just sketched out what I expect sort of an interface to look in order to solve a problem, and I notice that I have many things missing in my solution. And finally, if you're planning something like a backend solution, you can use like entity relationship diagrams that will help you to connect the dots between your data. So using any of these tools, and there's many more out there, it will improve your planning process. And when we get to the break in 10 minutes, I'd love for you to drop some of your notes in the chat, and perhaps we can discuss a little bit about what sort of solutions you use in order to plan your solutions. So once you have your plan in place, why not break them down into manageable tasks, like I mentioned earlier, the I need tos, and outline what needs to be done next. So as an example of sort of how I break down the problem into actionable tasks, if we're talking about exposing the data via my API to a client-side application, I know that I need to add an API. Well, I don't know it offhand, but I've done some research to know that I need to add an API endpoint to my backend application. I need to use my library to get my transform data, and I need to serve that data as JSON to my front end. That's how I'd expose the data via the API to the client. If I had to display data on the front end to the user, I know that, I mean, this will differ per library, etc., whatever you're using. But I mean, in general, you need to build a route for that particular page. You need to connect to the API endpoint and receive that JSON that it's sending. And then you need to use that JSON to build a graph. So I've broken down that problem into manageable tasks, and then I can tackle each task separately. Once you have your manageable tasks mapped out, you're ready to move to the next step. Sometimes implementing a solution requires you to carry out things in sequence, but it's often okay to choose a task with low effort but big wins. Feeling a sense of achievement and a sense of making progress is extremely, extremely important. Okay, so we've got our manageable tasks. What's next? So my next big win, especially for coding problems, is to write some pseudocode. Pseudocode is a detailed yet readable description of what a computer program or an algorithm must do, and it's expressed in a natural language, which makes it easy to talk about or to reason about. You can think about pseudocode as a sketch, a plan, or a blueprint, and so you essentially first focusing on the essentials, and you can leave the specific details for execution when you are confident that your outline or your pseudocode does the right thing. The pseudocode will essentially outline the steps in the process of developing the program. Beyond this, pseudocode also acts as a template of actually writing the computer code in the programming language of choice. One important benefit of writing pseudocode before programming is catching potential mistakes from the get-go. Again, it's far cheaper to fix mistakes before the developing process begins rather than after. Although these mistakes do happen after the development process and we deal with them as they come along, it's just a good practice to try and move them up front before the development process. I tend to write my pseudocode as comments in the appropriate file. So I have some sort of skeleton and then I just write some pseudocode. So here's an example of pseudocode for the problem that I was talking about. So for example, connecting an API endpoint and receiving data, that was one of my actionable tasks. So essentially what I do is I just write a small function and then I have sort of a comment that says I need to get API v1 movies, and then I have some sort of success state. In the success state, I need to build a graph. In the error state, I need to show an error message. So I'm not actually implementing the details. All I'm doing is writing comments on how this code should flow. If we look at like add data to the chart, and I've just used movies as an example of what data we're getting back from the chart, even though I said usage earlier. But we'd essentially be mapping through each movie, and we'd return the movie name and some data, which is maybe the number of times we've watched a movie. So writing it out in this manner gives you the opportunity to think at a high level without actually diving into the details. And finally, from there, we just use our programming language to implement our solution to the problem. This is the execution stage. So we're translating that pseudocode into actual code, and we keep doing this for subsets of the bigger problem. And eventually, we've connected all the dots and we've built our solution. So this is just an example of how the code would look once we convert the pseudocode to some actual code. And I think we'll break here and we'll do some polls and we can have some interaction. I'll hand over to Krystle.
Wonderful, thanks Ridhwana, that's really, really interesting. I was just thinking when you had that puzzle piece up, one thing that I was told many years ago, and it's kind of served me well, even to today, is somebody asked me, so how do you eat an elephant? And that's one bite at a time. And when I'm thinking, when I'm stuck and I have a problem or I'm stressed and I have a huge project ahead of me, I kind of think of that little analogy. So quite a cute one to keep in mind. Okay, so let's launch our first poll. I'm going to launch it. It's just a very simple one, yes or no, and then you can just vote and submit your answer. So here it goes. Great, I will give us about 30 seconds to a minute to answer. Let me see as they come through. So the question is, do you set aside focused or dedicated time to problem solve? And so far, I'm seeing most people are going for a yes response. Let's see as it builds up. Antoine, our co-founder and CEO, he says to everybody that you must be honest.
Ryan says that he's not able to see a poll on his side.
Oh, strange.
Perhaps if people are unable to see a poll, they can just pop it into the chat as well. We'll just count it from there.
Absolutely. So if you can't see the poll, I'll just read a question for you again. And that's, do you set aside focused or dedicated time to problem solve? And it's just a yes or a no answer.
One of my friends, Clara, says that she was honest, and it's definitely no.
Okay, Clara, we appreciate your honesty. Okay, cool. I don't see any more votes coming through. So we've got 7. So we got a little bit more. We'll give you a few more seconds. Okay, cool. I'll end the poll now. Great. Okay, so I'm going to share the results with you. So if everybody can see it on their screen, 72% said yes, they do set time aside to problem solve. And 28% said no, they don't spend time problem solving or set time aside for problem solving.
I think that was, for me at least, expected. I find that I have to really force myself to set aside, to like get myself into a focused sort of state. And sometimes I completely forget about it. So that was definitely expected for me, that poll number.
Okay, brilliant. So I'm going to launch our second poll now. And the question is, do you feel imposter syndrome when you ask questions to clarify that you understand a problem. So I think everybody feels imposter syndrome now and again. It's totally normal.
Ryan says yes, yes, yes. I found, I mean, I can just talk through this whilst people are answering, but I found that earlier on in my career, I definitely had much more imposter syndrome around asking questions to clarify. But I find that as I progress through my career, I realized that everybody doesn't know everything. And so I may be really good at a certain aspect of software engineering, whilst another person's expertise lie in a different area. And so there's no shame in being, firstly, a junior developer and asking questions, or even being a senior developer and asking questions, because it's actually both sides. As a junior developer, you're scared that people are going to think that you're incompetent and you're not cut out for the work. And as a senior developer, there's this expectation that you should know everything. But I find, and especially the culture that we sort of cultivate at Dev, we mostly a bunch of senior engineers on a team, and I found that the culture that's cultivated within the environment has been such that like, feel free to ask questions. Nobody knows absolutely everything. And I feel like a lot of this also needs to be cultivated by companies and making their employees feel comfortable to ask questions.
Brilliant. Yeah, absolutely. So I'm going to end the poll, and I'll share the results. We've got 60% that say yes, they do feel imposter syndrome when you ask questions, and 40% said no. And I think that's pretty much as you say. So it depends sort of where you are in your career and everything. I think starting out, it happens a lot more where you feel like in that space. So I think that's really interesting. And I think if anybody is wondering what imposter syndrome is, I'm sure I saw a question about that. Imposter syndrome is when you kind of feel it's when you don't feel like you're worthy of it, if I'm defining that correctly, whereas you completely are, but it's just kind of that feeling that you have just as a human being. So that's really interesting. So yeah, that's two polls that we have for now. So now we can open to questions. I'll stop sharing that. Okay. So if you have questions, I will enable you to answer live. So Antoine, I see you have a question. How do you mitigate this imposter syndrome? So if you can turn on your mic. Let's see if it works.
Whilst doing this, I find this very valuable and I can relate to this, but Clara mentioned that I find that I jump into execution immediately, and then sometimes I need to rework instead of thinking about the problem first, then think of a solution and only then execute. So I also find that very relevant, where if I don't actually dedicate our time, I actually end up having to go back and rework my solutions.
Absolutely.
And yes, Ezra, there's no stupid questions. Keep on asking.
Antoine, you should be able to speak now. I hope it's working for you. If you would like to ask your question. I think we might have okay, it's not giving him the mic. Okay. All right, so sorry about that, Anton. Let me ask on your behalf. So Anton's question, Ridhwana, was how do you mitigate this imposter syndrome?
I think, so I mean, imposter syndrome, a lot of early in my career, I felt like a fraud, like I wouldn't say I've mitigated it completely. I've got better with dealing with it. And the way that I do that is, and the way that I've done that is I've begun to have a realistic view of what the industry is. So I've now, like I mentioned earlier, I realized that everyone's expertise lies in different areas, and each person is good at something really different. So I realized that I can't be good at everything. I also, the way I mitigate imposter syndrome, and this sounds a little bit counterintuitive, but I ask questions. I force myself to ask questions. And as soon as I realized that nobody's looked at me like, oh my God, Ridhwana, why are you asking such a silly question? It already builds up my confidence to be able to ask more questions. So that I find that really helps. And the more that I learn and the more that I sort of apply myself, I feel like the imposter syndrome really sort of goes away. But it's a combination of being part of groups like this in good communities and people who are supportive that also really mitigates imposter syndrome for me.
Awesome. And I think I was just having a look at something that Clara said was on the previous file, she finds that she jumps into execution immediately. So sort of immediately going on to the solution before you've actually worked out, sort of doing the problem solving. So that's quite interesting. And I think a lot of people do that, especially with how time pressured we are. To get everything done and get it done quickly. So I think that's it's another issue. So is there a way that you can remind yourself to go into problem solving mode before you just jump into going for a solution?
The way that I do that is, and I mentioned this to Alice earlier, is I plan out my time. I use a passion planner and I literally put down dedicated tasks for the day. So just like how I break my tasks into more manageable tasks when I'm problem solving for my day, I do that as well. So I say, okay, I'm going to work on this specific thing for the next hour. And then it forces me to be in that mode where I'm not multitasking on a couple of different things. So I'm not focused. I literally just break up my time into smaller chunks so that I can be very specific and focused on what I'm doing.
So like a little bit of kind of time boxing helps.
Yeah.
Okay, awesome. Cool.
I also use the Pomodoro technique. It really helps for like time boxing and just dedicating out focus time, setting goals before you use sort of the next 25 minutes of your time. It really helps.
Can you tell us a little bit about the Pomodoro technique?
Yeah, so the Pomodoro technique essentially allows you to have, and I think the default is 25 minutes. If that's not enough for you though, because sometimes a problem takes a little bit more than 25 minutes to solve, you can just amend the times, but you set a goal for the next 25 minutes. You then have focus time for 25 minutes, so no distractions. And then you sort of execute at the end of the 25 minutes. You then take a 5 or 10 minute break, and then you start your next focus session. So the goal of the Pomodoro technique is to be able to set aside focused, dedicated times and to have a goal for that time. There's a cool app called Excellent if anyone is looking for like a little timer. I find that when I hear the timer ticking in the background, it really helps me to keep focused. Like I know, okay, my time is ticking. But Excellent is also a good app to use.
Okay, so it will either make you feel better or it will stress you out.
Yes, depending on what type of person you are.
And then I think we'll take this as our last question for now. So I have a question from Raphael, and he asked, when you hold back a question, is it imposter syndrome, or is it a confidence issue, or a sensing of irritating people and holding back progress?
I think it could be any one of those three, and it could be a combination of all three. Depending again on the type of person you are and your journey, it could be any of those. I found early on it wasn't really imposter syndrome for me, it was confidence. I didn't feel confident enough to be talking in a boardroom meeting, and especially usually being the only woman in the boardroom really early on in my career intimidated me. But as time passed on, I got used to it and I gained more confidence as I did more work, as I learned more things, as I started speaking at conferences and writing. I found that that goes away. Yeah.
Perfect.
I
No,
hope that
makes
kind of
sense.
answers your question, Raphael.
Awesome. All right. Shall we continue with the next part of our presentation, and then we'll go to our last polls at the end?
Yes, let's do that. So let me share my
Thanks for
screen
your
again.
questions, everybody.
Yeah, thank you. It was good to hear what other people do and to be able to sort of just validate things. Okay, so I am going to play. Are you seeing my slide?
Yes, we can see it.
Okay, perfect. I'm just confirming because I could literally go through the entire presentation showing the wrong screen. Okay, so we talked about how do we problem solve. We talked about some techniques and processes. And I've said that we should try and sort of preemptively plan upfront before we get to a solution. But often there's times where there's unexpected road bumps. So for example, taking into account the real world, we may have planned our route to work from Joburg to Cape Town perfectly, as per my example in the start of this presentation. But perhaps it was raining and there was an accident on the road, and now our plans essentially it's just going to waste. Well, it's not going to waste, but our plan isn't applicable any longer, and we need to sort of rethink our solution and perhaps divert our route. We may end up having a flat tire and our timing goes all out, and so we need to amend our solution based on these circumstances. So during this part of the talk, I just want to talk a little bit about how we deal with it and how we move forward, and then how do we secure a solution against future roadblocks. In the context of software engineering, I've essentially had times where I wanted to bash my laptop. There's a GIF of like someone picking up their laptop and bashing it against the desk. And I felt like that often when I'm stuck on some code, or I get unexpected bugs, or the requirements have changed, or a solution needs to be amended or talked through again. But it's all part of the process. And this is where these techniques will help to play a vital part in allowing us not to feel overwhelmed. So early on in my career, one of the most important skills that I was taught by my mentor was how to debug. And that was debugging when something doesn't quite work out as you expected it to. And it's the type of debugging I'm talking about is very related to software, but it can be applied to other things as well if you're solving problems in other domains. So the way to debug in the context of software engineering is to firstly be clear about how you're expecting your code to work. In programming, the easiest way is to essentially trace through your code using logs or halting execution of codes at certain points in order to be able to exploit. If a piece of code is particularly bad, you may as well spot other problems while you're fixing the original one. I found so many times, in fact, just last week, I was trying to debug a single problem and then I found 3 other problems, and you can essentially go on this tangent where you're trying to solve everything at once. But we really shouldn't do that. It's important to choose which problem you're going to tackle first and tackle just that problem. Often we can fall into the trap of trying to tackle too many issues at once, and thus we end up losing focus on our goals. And that's why using the Pomodoro technique, or even in the context of software engineering, making sure your PR does just one thing can really help to enable you to be able to just solve one problem at the time instead of trying to tackle multiple at the same time. The second thing I'd like to talk about is tests. Tests are really valuable to be able to catch bugs, and they allow you to upfront outline the behavior of the program. So if you're trying to build a solution, writing tests upfront will essentially help you to outline what that solution looks like. So just like how pseudocode helps you to do that, tests also help you to do that. Using something like behavioral tests will also help you to document your solution. So when anyone else comes onto that project, they already have the documentation to see how something should behave. When you're stuck and you write a test up front, you're also forced to think about the inputs and the outputs of that particular solution and what you're trying to achieve, thus giving you more clarity. If you're making any hypothesis or assumption, writing a test will validate that outcome as well. Writing these test cases to traverse your code and check its behavior will help you to find any errors early on, thus eliminating unnecessary bumps as well. Remember that the most common problems also that you encounter, somebody else has most likely encountered it as well. In the era of the internet, it's impossible to walk. It's not impossible to walk through someone else's thought process by reading their blogs or code about an issue similar to yours. Use the internet and don't feel ashamed to do your research if you get stuck. I mean, Google and Stack Overflow are my best friends, and they are there for me when no one else is there for me. So really use them. I copy and paste my errors into Google using appropriate keywords. My partner always tells me that I can really dig deep with Google, but I think he's talking about my stalking skills, but we're just going to pretend like he meant my ability to use Google to guide me through tech problems. Nowadays, I also use Dev too. I find that they have a lot of articles on topics that I'm working on, so it's nice to be able to do some sort of to be able to walk through people's thought processes using those articles. Medium as well, just different blogging platforms. This is my favorite technique, and it's called the rubber ducking method, which actually is rubber duck debugging method. So what I usually do, and I advise that you do this, is you beg, borrow, steal, or buy a rubber duck. There's many bathtub varieties. And you place the rubber duck on your desk and inform it that you're just going to go over some code with it, if that's all right. You explain to the duck what your code is supposed to do, and you go into detail and kind of explain your code line by line. At some point, you will tell the duck what you're doing next, and then you will realize, in fact, that is not what you're doing. The duck will sit there serenely and happy in the knowledge that it has helped you in some way. By describing what the code is supposed to do and then observing what it actually does, any incongruity between these two become apparent. More generally, I find that teaching a subject forces its evaluation from different perspectives and can provide a deeper understanding. When you're talking to your duck, you are being forced to break things down in really simplistic terms in a way that a beginner would understand. So this helps to remove all the junk from your application, and it helps you to demystify everything. Lastly, by using an inanimate object, you don't really have to interrupt anyone else. You're doing your first pass of like just explaining yourself. But at some point, if you really want to, you can substitute that rubber duck with an actual person. And imagine how great it feels to rubber duck with someone else who probably already has some awesome advice or insight into your problem as well. I mean, I find that I'm always surprised to see someone who has a coding dilemma pretty much identical to my own. And most of the time that actually happens. And usually that person has some advice to be able to help me to resolve my challenges. So the Socratic method is another approach that we can use, and it's a form of cooperative argumentative dialogue between individuals. And it's based on asking and answering questions to simulate critical thinking and to draw out ideas and underlying presuppositions. This method originates from the Greek philosopher Socrates. And when Socrates taught students, it was sort of a unique time for them in terms of how they approach this. So Socrates taught not by answering the questions proposed to him by students or asked by students, but rather by asking the student more questions in response. The method of asking questions forces the other person to think very deeply about the problem. And this is very different to the rubber ducking method. But when someone asks you questions in return, it helps you to make connections as you learn. His technique often involves finding gaps in one's knowledge and then patching them up with the answers to these questions. This fashion is effective, yet I would say that you should use it with caution, because if someone is already extremely frustrated and not in the correct state of mind after being really stuck on a problem or very overwhelmed, sometimes this method isn't the right one to use. So use this technique with care and at the appropriate time. So finally, these are just some of the most common ways that I and many other people overcome the hurdles of problem solving within software engineering. But most of what I've talked about can also be applied, like I mentioned in the start, to any problem. There is no better feeling than solving a problem. And once I've solved a problem, I'm often caught up in a whirlwind of activities on what's next. Like Krystle mentioned, there's always another deadline. However, the thing that I personally like to do more often is to reflect on the problem and the way that I've solved it. So what I've done previously is I found that when I reflected on a problem, I was always able to tweak or optimize my solution in some way, and even think about how I can apply the solution in a broader sense. Many a times I write a blog post about it too, and it helps me to put my thoughts in perspective to help future me when I stumble across a similar problem, and also just to share my knowledge with the world. And the main thing is to always feel proud of yourself when you reflect upon the process. It builds up your confidence for the next problem that you're about to solve. All in all, the reflection process is the best part of the process to get to, because it feels like the calm after the storm, and it's time to bathe in your glory of hard work. I'd like to end this presentation with a quote that really resonates with me, and it says, "Successful problem solving requires finding the right solution to the right problem. We fail more often because we solve the wrong problem than because we get the wrong solution to the right problem." And with that, I'd like to say thank you to you all for listening to me and for the first part of the interactive Q&A. I'll now hand over to Krystle.
Awesome. Thank you so much, Ridhwana. I think that was extremely interesting. And I've always heard of the technique of rubber ducking, but I never thought it was actually buying a rubber duck. So that's fantastic. I think I need one of those. All right. So I know we've run over a little bit, so apologies for that. But I think if you are able to, we have 2 more polls, which could give quite some awesome insights. So I will launch the first one now. And this one is a multiple choice. So there's a few options. I'll launch it now. And this says, what is the most difficult part of problem solving for you? And this has various options. One is understanding the problem. The second one is breaking up the problem. The third one is planning a solution. The next one is writing an outline for the solution or pseudocode. And the last one is actually executing. So I'll give you a few minutes to vote on that.
Krystle, which one would you say is one of the most difficult parts for you?
I think it would be probably, because I think often I would probably go straight to executing. So it's probably taking a step back and sort of breaking it up into little bite-sized chunks. I think that could be it.
Yeah, I think that also for me is one of the things I have to constantly remind myself.
And for you, what's the most difficult part for you? Is it the same?
I think it's breaking up the problem, or sometimes even planning a solution. I feel like I just go straight into executing without actually planning it out. I do tend to write a lot of pseudocode before I do anything, so I guess, but I can miss the breaking up a problem and planning a solution.
So about having that discipline of allocating that time to it.
Yeah.
Okay, so I think just in the interest of time, I think we've got most of the votes. I'll stop the poll now. Okay, let's see. I'm going to share the results with you. And I think most people voted understanding the problem. That was 53%. And The next, I think it's equal between breaking up the problem and executing. Those are equal. And the lowest one was planning a solution.
Okay.
Quite interesting.
That's interesting. I really did think that the highest value here was going to be breaking up the problem. So
Yeah.
this is really interesting.
Very interesting. And I would like to launch the fourth one and the final one. And this is also a multiple choice question. And the question here is, which method do you use most frequently to unblock your execution? So the first one, debugging, that Ridhwana mentioned, writing tests if you're a software engineer, Googling or Stack Overflow, rubber ducking, or the Socratic method. So which one do you use most often, Ridhwana?
I would say that I use I think rubber ducking method, and not necessarily always with a rubber duck. I tend to talk to myself a lot whilst I'm coding. And although recently I've been using, I mean, debugging is just a part of my everyday process. But the thing that I'm really proud of recently is that I've started testing, and especially on the front end. Back end testing is fine, but on the front end, it was like a challenging uptake for me to be able to write tests. And I've really found the value in writing tests to be able to sort of upfront think about the problem. But I must say, I use a combination of all those techniques.
So that's probably a better way to approach it, is sort of combining techniques.
Yeah, definitely. And some of them are just part of the natural process of sort of coding. What do you find that you use most frequently?
I think the good old Googling. Google has absolutely everything and anything. So that's probably the easiest one. But I kind of like this rubber ducking. I think I need to try this out. I'm very intrigued. Ryan says rubber ducking. So yeah. Okay. So I think I'll stop it here. And I'll share the results with you. So we see that 50% actually use debugging, which is really interesting. Then the next majority is Googling and Stack Overflow. And then equal is rubber ducking in the Socratic method. Very interesting.
Yeah, I find the Socratic method is really great. I find that when I'm using it, if I'm expecting it, that's when Socratic method is really great for me. If I'm not expecting it, it can really go either way.
So I have a question about that. I was just wondering, with the Socratic method, who would you sort of engage to have that discussion? Would it be someone knowledgeable in what you're working on? Would it be sort of an outside party?
It depends on the type of problem that I am trying to solve. It would always be someone that at least has some context, so that that would understand the context while I explained it to them. So for example, I wouldn't ask a random family member that knows nothing about the problem. It would usually be a colleague that would be able to give insights. And sometimes I'd ask someone that knows a lot more about the problem than myself. But sometimes, depending on the type of problem it is, I might ask someone that I know may know less about the problem, but who would see it from a fresh perspective. So depending on the type of problem, it would be either those two types of people.
Okay, that's really, really interesting. Okay, so I don't see any more questions. Does anybody have anything else that you'd like to ask before we go? But if you do think of something, feel free to reach out to us, either through social media, or you can email me or Ridhwana, and we'll help you out there for sure. So thank you so much. This has been, I think we have one question. Let's see. So Bertus, he asked the question of, when you are trying to learn a new skill, how do you determine how much you work on it yourself before turning to Google or Stack Overflow?
I think I only turn to Google or Stack Overflow when I'm stuck. So when I'm learning a new skill, I always read through documentation. So say if I'm I read through any documentation that there is, I read through blog posts, but I don't necessarily turn to Stack Overflow to give me a solution. The only time I turn to Stack Overflow for a solution is if I'm really stuck on something. Yeah.
Okay, perfect. So when you stuck, pull out some of those techniques. Okay, great.
Yeah. I think it's not as useful when you just immediately turn to Stack Overflow and just copy and paste a solution from there. It's always sort of better to process it yourself first.
Okay, that's interesting, because sometimes we don't give ourselves enough credit that we might actually have the solution already up there. So give yourself a chance to come up with a solution. Awesome. So thank you so much, Ridhwana, for your time. That was really, really interesting. And thank you, everybody, for joining us. We really appreciate it, and we hope that it was fun. Sorry that I couldn't turn on your mic. Next time we'll set out a bit more time for that. But it was nicely interactive, and I enjoyed it too. So thanks very much.
Yeah, thank you so much, everybody, for attending. And I really enjoyed the sort of interactive portions and the polls. I had loads of fun. Thanks.
Awesome. Thanks. Have a great day, everybody. Bye.
Bye.